Good day, everyone. I'm Sir RJ Leeson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about illustrating and verifying relation and a function. So before we proceed to our main lesson, let's have an activity first. Use an arrow to connect each quantity in set A to the corresponding quantity in set B. Answer the question that follows. So question number 1, we have Mr. Reyes is a dealer of poultry eggs. He sells them at 210 pesos per tray for the large size of eggs. The following are cost of each number of trays. Now, in one tray, the cost will be 210 pesos. So let's connect that one from set A to set B. So we have here, and if we will buy 2 trays, that will be the cost will be 210 times 2, so that means we have 420. 3 trays is to 630 pesos, 4 trays is to 840 pesos, and 5 trays is equal to, the cost will be 1,050 pesos. Number 2. Beverly is cleaning the house. Help her to complete the task by drawing an arrow from set A to set B. So we have here set A is the things in the things in the house, and set B is the places in the house. So for example, the cup. So where can we find the cup? So in the kitchen, right? The pillow, so in the bedroom. Toiletries in the comfort room. Blankets in the bedroom. Plate in the kitchen, and bedsheet into bedroom. Number 3. Given a number 6 is a set A, which are its factors in set B? So what are the factors of 6? So the factors of 6 is 1, 2, 3, and 6. So the question is here, what is a relation? So a relation between two sets is any ordered pair containing one object from each set. So that means the elements of the first set where the arrows come from are called the domain. So the first set there, so in the left side facing the screen, that means the set there is called the domain. While the elements in the second set where the arrows end in the right side facing the screen is called the range. The reason of a rule that you will follow to make this mapping, that the mapping of its relation of the two sets. So we have here another example. We have x and y. So the x here is the domain and y is the range. So that means the sets or the element, the set x, the element of the set x here is 0, 1, and 2. And then the element of set y, which is the range, that which we have -3, -1, and 1. So this is the domain and the range. So in relation also, there are different kinds of relation, which is one of this is one-to-one relation. So if every element of the domain is mapped to a unique element in the range, so we have here, so that means in one-to-one relation, so there must be one element in set A that you will pair also in one element in the set B only. So we have here example here in the number of trays and the cost of each tray. Next, we have many to one. So if two or more elements in the domain are mapped to only one element in the range, so that is many to one relation. So example for this one is the objects in the places in the house, right? So we have here many to one. So we have here, for example, here the cup and plate is paired by in the set B, which is the range here in the kitchen. So many to one. Another example here in the set A, we have pillow, blankets, and bedsheet paired to many paired to the bedroom, which is in the set B here. That is an example to many to one relation. Next, we have one to many. If each element of the domain is mapped to any or two more elements in the range. So that is a one to many element. So one to many relation rather. So one, so we have here example number 3. The factors of the set A is the 6, and set B is the factors of 6. So which is 1 number the 6 here is paired to 1, 2, 3, and 6. So 1 to many. Okay. And we have also another one, which is a combination of many to one relation and one to many relation is called many to many relation. So that means we can pair, for example, this one, many to many ne, because so number 3 here is paired to 5 and 6, or in the range is paired also to 1 and 2. So 1 to many and then many to 1. So that is many to many relation. So there are other representations of relation. So aside from mapping, which is those are examples, previous examples na sa previous slides. We've already discussed the mapping of relation. A relation may be represented in 4 other ways, which is the table, ordered pairs, graph, and equation. So we have here relation expressed in tables. So relation between two variables can be presented by tables. So the table below illustrates the relationship of the two quantities, which is Mr. Reyes is the dealer of poultry eggs. So the table shows the cost of the tray, the number of trays is the X, and the cost of in peso is Y. So represented horizontally and vertically. So it's either the two. So main is the X and the Y is the range. So you need to remember that the stated first set will be the domain and the second stated set will be the range. So this is the range and this is the domain. So other than mapping, so table is considered to be representation of relation. Another representation will be expressed in ordered pairs. So based on the sample problem above or on the previous slide, the following ordered pairs will be derived from the relation between the numbers of trays and the total number cost. So number of trays paired by the total cost. So in ordered pairs, we have here, if one tray, which is 210 pesos, if two trays, the cost will be 420 pesos. If three trays, it will cost 630 pesos. If 4 trays, it will cost 840 pesos. If 5 trays, it will cost to 1,050 pesos. And in general, as X and Y, so ordered pairs. Relations expressed as the rule of equation. So a relation may also be represented through the equation in two variables or a certain rule expressed in equation. Now, let us model the relationship of the cost of the number of trays, the eggs through the equation. So, the total cost equals the cost per tray of eggs times the number of trays. So, we have here if 210 is the total cost. So, that means the total cost per tray. So, we have 210 and then number of trays. So, that is equal, right? 210 times 1 is 210. Next, if we have 2 trays, so that means the total cost will be 210 times 2 trays, so 420. 210 if 3 trays, so 630. 210 if times 4 trays, so we have 840 pesos. 210 times 5 trays, we have 1,050. So that means then Y is equals to 210 times X. So the Y is the total cost and the X is the number of trays. Is the rule to express through the equation in two variables. So using the equation or existing rule, Y equals 210X, we can determine the number of total cost of the number of tray of eggs sold. The set value of X is the number of trays represented by the domain, and the set of values of Y is the total cost in pesos represented in range. So relation can be described also in graphically. So below the graphical representation, relationship describes It illustrates the relationship between the total cost of the number of trays of x. So we have here the x-axis, where is the x-axis? So here, the x-axis is the number, represents the number of trays of eggs, while the y-axis, this one, is the total cost in peso. So we can plot, no? If you have, for example, the given table there, or the given ordered pair, no, is presented na, and you were asked to make a graphical representation, or graphical representation of relation between the number of trays and the cost of eggs and the number of trays. So you will, the representation is look like this. So for example, one tray, so 210 plot, two trays to 420, then three trays we have 630, four trays we have 840, then 5 trays we have 1050. So that means you can make increasing line out of it. No? So what is a function? So a function is a special type of relation. So it is a relation where no elements in the domain is mapped or paired to more than one element in range. So going back to the different types of relation, which of them can be called a function? Again, what is a function? No element in the domain is mapped or paired to more than one element in the range. So we have here, by looking at the definition of the function, one-to-one relation and many-to-one relation are functions, while one-to-many and many-to-many relation is just a mere relation. Again, what is the different kind of function? One-to-one relation and many-to-one relation. Okay, so this is a famous kining quote to remember. What is the difference between relations and functions? So all functions are relations, but not all relations are functions. Kung bisayaon pa, tanan function kay relation, pero dili tanan relation mo function. Okay, you need to remember that quote. Okay? So let's examine the next example, further understanding the illustrating and verifying relation of a function. So example number 1, determine which of the following set of ordered pairs is a function. So we have set A, 3, 5, 2, 7, 4, 6, negative 3, and negative 5. Again, what relation considered to be a function? So that means that we need to identify one-to-one relation or many-to-one relation only. So let's look at the domain. So one-to-one dapat class. So dapat ang first niya nga element, no, sa atong, or first set na to class sa atong, ang mga elements niya dapat dili the same. That means distinct sila. So in set A is a function since there are no distinct ordered pairs having the same first element. No, you look at the first elements of the given set. No, there are unique. So there are distinct class. So in set B, we have 0, 1, negative 1, 2, 0, 3, negative 2, 4, negative 1, 5. So set B is not a function since in the ordered pairs 0, 1, and 0, 3, nagbalik ang 0 class. So have the same first element. So that means that is not a function. Again, a function may either be one-to-one function or many-to-one function. Next, in set C, we have set C is negative 1, 2, 1, negative 2, negative 2, 16, 2, negative 16, negative 3, negative 54, 3, and 54. Set C is an infinite set. Why is it an infinite set? So there is a ellipsis here, right? So that means we don't know where the end of the elements here. But the pattern shows that are no abscissas with the same value. So that means no, first term daw is nagbalik-balik class. No, you look at negative 1, 1, negative 2, positive 2, negative 3, and positive 3. So that means set C is a function. Now let's proceed here to identify or to verify if the given graph is a function. So let us remember this one, vertical line test. So this is a test which use the vertical line test to check whether the relation expressed in the graph is a function or not. If every vertical line intersects the graph not more than once, then the graph represents a function. So example number 2, a graph can be identified whether the function or a mere relation by using the vertical line test. So for example, this one, so we have here a graph here. So when you make a vertical line test, you can make a vertical line test in it depends on you. Basta you can make as long as you will make a vertical line test. So if the line test will intersect just one point, that means that is a function. So the graph in A is a function since the vertical line test touches the graph at exactly one point. Even if it is moved to the right or left, it will just touch just one point of your given in the given nato nga function or given nato nga line. Next, we have here B. So you look at here the graph, no? Pa curve siya. So when you make a vertical line test, no? Even if you move to right or to left, no, there are many points here as you observe na ni-intersect. So that means the graph B is not a function because if we examine the vertical line test, it touches the graph more than once. Again, a function lang siya class if one point lang ang iyang matouch sa imong line. So if more than one, that means that is not a function. So letter C here, so we have here pa V ang iyang graph, right? So pero when you make a vertical line test, it just touches one point lang of your given line or a given graph. Examining the vertical line in graph C, it touches the graph once. Hence, the graph C is a function. Even if you move to left or right, no, it just touches one point of the given graph. So here, in example number 3, determine whether the given equation is a function or not. So we have here given examples. So example number A, so we have here 3x minus 2. Example B, we have y equals to x squared plus 1. Example C, we have y squared is equals to x plus 1. Y cubed, we have x squared plus 2x. To determine if the given equation is a function, let us assign a test value for x and substitute it to the given equation. If one values of the domain yields exactly a unique value of its range, then the equation represents a function. Otherwise, it is not a function. For example A, so we have y equals to 3x minus 2. So let us take x is equals to 1. So you can let any values here in finding the value of y. So you can let x as 1, 2, 3. You can identify it. You can make your own value. You can set your own value there. So substitute the value of x to y equals to 3x minus 2. So we have here y equals to 3 times 1 minus 2. So we have now 3 times 1, we have 3. So 3 minus 2, we have y is equals to 1. So that means the ordered pair is 1 and 1. So is it a function or not? There is only one value of y and one value of x. So therefore, y equals to 3x minus 2 is a function. Next, we have y is equals to x squared plus 1. So let us take x is equals to 2. Substitute these values of x to y equals to x squared plus plus 1. So we have here y equals to 2 squared plus 1. So 2 squared is 4 plus 1. So we have y is equals to 5. So the ordered pair is, so if your x is 2, your y is 5. So there is only one value of y for one value of x. So therefore, y is equals to x squared plus 1 is a function. Example C, we have y squared equals to x plus 1. So let us take x is equals to 3. Again, if you're going to represent the value of x class, you can use any values. So substitute the value of x to the equation. So we have now y squared equals to 3 plus 1. Extract the square root of the both sides of the equation. So we have now, diba, 3, y squared is equals to 3 plus 1, we have 4. So, diba, class, so how to extract y here? So we need to square root both sides by, square both sides to get the value of y. But then, in the rule, in finding the roots, diba class, that means there are two possible solutions, positive and negative values. So that's why we will write here in finding the roots, no, positive and negative. So that means we have y is equals to positive and negative 2. So the ordered pair now is 3 and 2 and 3 and negative 2. So if your x is 3, so your possible values for y is 2. And if your x is 3, your possible value also of your y is negative 2. So there are two values of y for one value of x. Therefore, y squared is equals to x plus 1 is not a function. So if you look the given answer class, no, ikaduha nagbalik si 3. So that is an example to one to many na. That means that this is a mere relation only, not a function. Next, we have y cubed equals to x squared plus 2x. So let us take x is equals to 2. Substitute these values to the x of the equation. So we have here y cubed is equals to 2 squared plus 2 times 2. So we have here y cubed is equals to 4 plus 4. So we have here now 4 plus 4, we have 8. So we can extract y here using the cube root, diba? We need to cube root both sides. So cube root of y cube. So we have y, and cube root of 8 is 2. So the ordered pair, if your x is 2, your y is 2. So that means there is only one value of y for one value of x. Therefore, y cubed equals to x squared plus 2x is a function. Now, for your activity, no, you need to copy and answer this one in a one whole yellow paper. And then you submit during the resume of our class. So as part A, we have determined whether each relation is a function or a mere relation. So just follow the examples, no, we have discussed in the previous slides how to determine a function or a relation. Next, we have identify the following equation is a function or not. You need to show your solution and explain your answer. So you need to follow also the instructions, no, based on the previous slides. And then we need to determine whether the following graph is a function or a mere relation, and then describe each graph. Now, we've already discussed in the previous example how to identify if the graph is a relation or a function. So you will use the vertical line test, and you need to answer the guide questions there below. Thank you so much for watching. I hope that you've learned something out of this lesson. Please don't forget to like and subscribe and share it with your grade 8 friends. Thank you so much, everyone. Goodbye.